Hey fourth graders, let's do a quick review of area model of multiplication before we move on to partial products. Now we did this last week, but I want you to have a resource just in case you need to look back at something to refresh yourself. First thing that we do when we have a multiplication problem that we're solving using the area model is break our numbers apart by place value. So our problem or equation is 24 times 16. I want to break those numbers down. I'm going to start with 24. I know that 24, the value of the 4 is in the ones place, so it's going to be worth 4 ones. I'm going to put that over top of my 4 ones that I've already got up here. The value of the 2 is in the tens place, so it's going to be worth 20. So I have my 2 tens represented across the top. This is my 24. 2 tens, 4 ones gives me 24. So I've broken that apart. Next one I want to break apart is 16. The value of the 6 ones is 6. So I'm going to put that next to my 6 ones down here on the side. And the value of the 1 is 110, aka 10. So I'm going to put that right next to my single base 10 right here. Now that I've broken my numbers apart, I can go ahead and start multiplying. I've gone ahead and set up our problem just for the sake of efficiency. The reason why we want to break those numbers apart is because it creates simpler problems for us. And we always want to simplify problems because it helps us to be able to do math more efficiently and also to be able to do it mentally. And that's something that we want to work toward. Now that you've got your numbers broken apart, we want to start creating little boxes for our areas. So I'm going to look to start making my columns first, then I'll make my rows, and that will create 4 boxes. When I make my columns, I want to consider which is the larger number here. So I have 20 and 4. I know that 20 is much larger than 4, so I'm going to give it more space in our area model. I'm going to give it a much larger column. Now I'm going to make my rows. I have 10 and 6. Well, 10 is going to take up a lot more space than 6, so I need to give it a larger row than I give to 6. And I can finish out my boxes down here. And this should create 4 nice boxes for me to be able to multiply in. The size of the boxes also helps me to know how large the products of the multiplication problems are going to be, so it's already a nice clue to us about which problems are going to create the biggest products. If I look, I already know that 10 times 20 is going to create a much larger product than something like 6 times 4. So I'm going to go ahead and set my problems up. I'm going to write them in the boxes before I do anything with my base 10s just to make sure I've got it completely clear. I'm going to start with the top left box, and that's going to give me 10 times 20. I'll then go over to the right for my top right box. That's going to give me 10 times 4. Then I'll go down to the bottom. This is going to be 6 times 20. And then my bottom right box is going to be my smallest product. I can already see that visually. We have 6 times 4. All right, let's go ahead and solve. I'm going to use my base 10s to help me, but I'm also going to use what I know about multiplication. So first thing I see is 10 times 20. I want to look at that and make it a simpler problem. So in my mind, I'm going to ignore the 2 zeros and just make this problem 1 times 2. Well, I know that 1 times 2 is 2, and I've ignored those zeros, so now I have to put them back. So I'm going to do 1 times 2 is 2, and then I'm going to put those 2 zeros back since I've ignored them. That's going to give me a product of 200. I can also do that with my base 10s. If I have 10 groups of 10, that's going to give me 100, and I'm going to use my big 100 block for that. It's a little bit faster. And then 10 times 10 again is going to be another 100. So 10 times 20 then must be 200. Then I'll do my 10 times 4. Again, I can do the same thing. I can cover up that 0, and I'll know that 1 times 4 is 4, so I can go ahead and write that in, and then I'll put the 0 back where it belongs, 40. I can also show that with my base 10s. I'll bring 4 separate 10s over. So that's 10, 20, 30, and 40. And I'm going to move down to this bottom box. I have 6 times 20. I can do that same thing. I'm going to ignore that 0 for a moment. I know that 6 times 2 is going to give me 12. And since I ignored one zero, I have to put it back in for my final product. So 6 times 20 is going to give me 120. I'm going to have to drag all these 10s down into my model. So that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. My last one that I need to do is 6 times 4. That's a math fact that I already know. I know that 6 times 4 is going to give me 24, but I want to just double check and prove that with my base 10s. So I'm going to need to drag a bunch of these little ones and create an array that is 6 rows by 4 columns. So I'm going to set up my rows here down the side. This will be my first column, but I'll have all 6 rows. All right, and then I'm going to see if I can copy this, make it a little bit easier. See if it will work with me here. Nope. All right, keep dragging. When I finish creating my 6 rows with 4 columns, I should be able to count up 24 squares. That's the goal we're looking for here, to prove that our original equation that we solved using that math fact that we know is correct. Ooh, we need to make some more. And so far I'm looking and it seems like we've got this right. We're going to have 6 times 4 equals 24. I can count that by 4s, 4, 8, 12, 16, 20, 24. I can count by 6s, 6, 12, 18, 24. I can count them individually. Now that I have all 4 products of the 4 individual equations, the last step that I need to do is go ahead and add them up. So I'm going to go ahead and do 200 plus 120, and that is going to give me 320. And then I'll do 40 plus 24. That's going to give me 64. And then last but not least, I can go ahead and add those together. And 320 plus 64 is going to give me 384. So my final product of the problem is going to be 384. And that is how we use the area model of multiplication.